We have three different types of rocks. We have igneous, sedimentary, and metamorphic. Okay, so we have igneous, sedimentary, and metamorphic rocks. Okay, igneous means Latin from fire. These rocks form when magma cools and hardens. Sedimentary rocks are when sediment deposits harden after being compressed and cemented together. They will form sedimentary rocks. And then we have metamorphic rocks, and metamorphic means change form. So metamorphic rocks are the only rocks that are actually existing rocks, but they're going to undergo a change from heat and pressure. So metamorphic rocks are going to be these two things right here that are going to undergo a change, and when they do that, you're going to create a different type of rock called metamorphic rocks. Igneous rocks. There are two types of igneous rocks. We have intrusive so we have intrusive, and the key word in that when we look at it is the word in. Okay, and these are igneous rocks that have cooled inside of the earth, and by cooled we're talking about magma that is being cooled. Extrusive rock, igneous rocks, these are rocks that have been cooled on the outside of the earth. So the key is here is extrusive, like exiting, like they're out of. We have formed from crystallization of magma. That is what igneous rocks are. Okay, and we have some rock forming minerals. So from our minerals units, we have biotite, feldspar, olivine, quartz, and mica. These are the main building minerals of these rocks. So we can have any one of these three, any one of these two, any kind of combination going on to get these rocks called igneous rocks. Group 1 is called the mafic, and the mafic basically has biotite, feldspar, and olivine in it. Group 2 is felsic, and they have quartz and mica in them. The next type of rock that we have is called sedimentary rock. These rocks form from the cementing of rock fragments carried away from their source by either water, wind, or ice. We have, within the sedimentary rocks, we do have a couple different types of sedimentary rocks. We have clastic. Clastic, they are classified by the size of the sediments that they contain. So an example would be conglomerate or breccia, and I have a picture right here. And clastic is, you can see the rock fragments, like the little pebbles that are all cemented all together. That is a conglomerate rock, and it can get then further classified by the size of these that we see, by the size of these pebbles and rocks that we can see within this, then we'll further classify that rock. We have chemical, and chemical means simply that they have a chemical origin. These rocks form from minerals that were once dissolved in water. Okay, so here we have an example. This looks like calcite to us. That mineral calcite that we were working with is an example. This one right here is called gypsum, and calcite would be part of that. But anything that was dissolved in water once, so you can have NaCl, also known as rock salt. Okay, we have the calcite, gypsum is right here. Anything that was once dissolved in water, we can get it to be, is considered to be a chemical. Then we have organic, and this would be number 3. And that is our organic sedimentary rocks, and they form from remains of living things. So a big example to us is coal. We do use coal quite a bit, and Coal is a great example. Here is a picture of it, of something that comes from something that was once living, which means that they will have carbon. The element of carbon within them. We have some features that come along with sedimentary rocks. We have something called stratification. And stratification is the layering of sedimentary rocks. So we have an example right here that occurs when there is a change in the kind of sediment being deposited. So here you have a layer, and then the deposit changed. So now you have a different type of layer. Here's another deposit change. Here's some more deposit changing. So you get this stratification or very much layered look. So if you are going to understand what stratification means, layered would be a great term to use. We can all get things like this, or the ripple. We can get things called ripple marks or mud cracks. Ripple marks are made by the action of wind, water on the sand. Mud cracks occur when mud dries and starts to shrink. No different than what we see basically outside our backyard when you have a spot that is very muddy and then it dries out, and when you can tell when we haven't had rain for a while and you get those mud cracks in them. Those mud cracks can then affect some sedimentary rocks, and you might see that actual event stay in that rock. Ripple marks, here is an example right here of the picture that I showed you. I'm showing you, you can see the ripple effects right here of basically the outside elements taking upon this sedimentary rock. And so now a feature of this rock is the layering look that we see. Another big one that some of you might be really interested in are fossils. And fossils are the remains or the traces of ancient plants and animals. They're usually preserved in sedimentary rocks. So here's an example right here of a rock that has several different sets of fossils in them that I'm kind of circling here for you. Fossils are going to prove to be key for us when we talk about the geologic timeline, because without fossils we would not know, or geologists would not be able to put together an idea of animals that were extinct, the ideas of evolution, the idea of what our planet looked like prior to today, without the use of fossils. Third and last type of rock that we have is called metamorphic rock. And basically, I was telling you before that this is an actual rock. It comes from either sedimentary or igneous rocks, but what happens is heat and pressure, a great amount of heat and pressure are applied to these rocks, and it causes these minerals to actually change into other minerals. So just by simply putting pressure and heat onto some of the minerals, we can make them change, and when we do that, we get a metamorphic rock. Because now it has different chemical properties and different physical properties than the rock that it used to be. It can change any rock as long as you apply a good amount of heat and pressure. We can have, again, two different types of metamorphic rocks. We can have foliated and non-foliated rocks. Foliated form from extreme pressure, and they flatten the mineral crystals in the original rock. So here's an example like this. And when it does that, it gives us this appearance of light and dark bands. So you can see here's a light band, and then we have a dark band, and then here's another example of a light band in there. So it gives you kind of that ribbon look and different colored layer look. And that is an example of a foliated. That means all the crystals were flattened in that mineral from that rock, and they are flattened out, and they give you that nice, they call it a different band look or a nice layered look. The last type of metamorphic rock is called non-foliated, and they have actually no bands of color. They have quartzite in them, which form when sandstone is metamorphosized. Basically, it's changing the quartz, which exists in sand. And sandstone is just simply sand that has been cemented together. Literally a stone made out of sand. So you're going to have lots of elements like silicon in there. And you're going to get the mineral quartz. And when quartz is put under a lot of pressure and heat, it will not give you these nice flattened out, like these nice flattened out color. It basically looks like another igneous rock. However, the crystals are a little more flat than they would be. And you do get this nice different colored effect. So here's white, and now we have, the dark coloring over there. Here's another flattened out crystal right there. And so that ends our discussion about the three types of rocks. We have igneous, metamorphic, and sedimentary rocks. And now in class we're going to start to use these notes and go through several different activities to understand how each one of these impacts the Earth and the geologic timeline.